Talk about the supervised learning. I want to repeat again the important concepts of supervised learning. Okay, in supervised learning we have data sets in the form of labeled instance X and Y. Y is your label, X is your data. And then every data has its own features. Features, what is features? Attribute value pairs, which characterize each data. Okay, attributes means something that can describe your data. For example, in your data sets here, we have attributes ear, for example. Ears equals to pointy. How about this one? Okay, as well, the same. Ear equals to pointy. This one, ear equals to long. This one, round and big, for examples. Okay, so everything that can describe your data is called features. Now, you need some evaluations to decide how good is your model. So we use accuracy here to see whether our model is good enough or not to predict the new data that we never see. Okay, how we calculate the accuracy is something like this. So this is a very common method to calculate the accuracy. Actually, the accuracy is simple. Everything that you can predict correctly is accuracy. Yeah, for example, you can predict from 10 dataset, okay, 5 datasets. You can predict, this is your prediction, and this is the actual label. Still remember, spam not spam? Okay, in spam not spam, for example, first in the first datasets you can predict this is spam, this is not spam, this is spam, this is spam, this is spam, for example. And the actual label says like this: spam, not spam, not spam, not spam, not spam. So how to calculate accuracy is easy, because this is correct, this is correct, this is incorrect, this is incorrect, this is incorrect. So you have only 2 out of 5 accuracy, or equals to 40%. This is very bad, because you only can predict 2 out of 5 correct. Okay, so you can also use the confusion matrix. Yeah, confusion matrix is like the confusion. So you want to see whether your predictive values versus the actual values match or not. Okay, if you predict positive and then the real actual value is positive, you can calculate this as true positive. Yes, you can classify cat as a cat, so this is true positive. And how about the true negative? So for example, not a cat, so this is mean dog, and then the actual value is dog. So you can predict, your model can predict this is dog, and actually this is real dog. So you can predict correctly. Okay, based on this confusion matrix, you can see that your model accuracy is 70%, better than this one. Okay. Okay, so accuracy from dog cat classification equals to true positive plus true negatives divided by whole data. So 70%. Okay. Now, how about the overfitting? Overfitting means your model is too good for the training datasets. That's why they cannot differentiate, they cannot see clearly how your new data can be classified. Okay, for example, this is called overfitting. You teach your machine to differentiate between bananas and not bananas. And because your your model is very good, like 99% accurate, yeah. When you train to the datasets, when you test to the datasets, it's 99% accuracy. That's why when your machine see one banana like this, they cannot see clearly whether this is banana or not. So instead of saying this is banana, they will classify this as not bananas. Okay, because this is overfitting. Okay, now about two types of supervised learning. We know that our data can be classified as discrete and continuous. Still remember, discrete is anything that you can list. Continuous is anything from 0 all the way up to positive infinity. Doesn't have any breaks within this interval. So for discrete, we have classifications. Yeah, and then for continuous, we have regressions. Okay, if you heard about the classification problem, that must be a discrete function that they want to predict. And the other way around, if you heard about the regression problem, that means they want to predict the continuous functions. Okay, what is discrete function? Discrete function is something like this. Cat, dog, can, spam, not spam. This is your classification problem. How about regression? Regressions, you can predict something like this: 1.001, 1.002, all the way up until whatever your maximum function, 10 example. So what you cannot differentiate between this number and this number. Okay. Next. Okay, this is a bit about the different classifications. You can differentiate between spam, not spam, with a clear boundary. Regression problem is something like this. This is your features about the house, yeah, selling price of the house. This is your features and this is the price. Price can be ranges from here, $1, for example, $100, until way up until $300 and in between. There's so many points in here. And this is called regressions. You can predict based on the data. It can be like this. Like this. So given the features, you can predict whether the price is low or the price is higher, like this. This is regression. So how about the clustering? Remember k-means? You just cluster the data. Make your own label. Make your own classifications. Okay, now how about the classification examples? It's a lot. Our job is to predict label for input X. Okay, the example is OCR to read the image and then suddenly you can read the text. Okay, when the classes is characters. And then medical diagnosis, automatic easy essay grader, fraud detections, customer service email routings, and many more. Okay, in the classification, we have two-step process. In step 1, we build the model constructions, describing a set of predetermined classes. Label, yeah. And then, in the next step, we use the model for classifying future unknown object new data. Okay, and then estimate the accuracy of the models. If the accuracy is good, then we can use the model. So based on the data, you build your model. You have model, and then this is new data. You can predict. Okay, this is the illustrations from a set of data. You will have learning algorithm based on the induction model. We have model. Learn the model, and then we have the model here. Now we have to apply the model and then deductions. Finally, we can predict this unknown data. So this data is not in here. Yeah, this is completely new. 10, this is 11. So this is completely new data. Okay, still remember what is induction? Induction is start from the example and then we start to generalize. That's why we can see clearly the model. Then start the deductions. Go back again to make it specific for each data. Okay, this is some common technique in classifications. We're going to talk about this, decision tree. Role-based method is like similar like decision tree. Naive Bayes, we already talked about this. Neural network, we're going to talk this next week. We're not going to talk this one, and many more. Okay, so this is your discussion topics. Think of any real case study next to you which can be solved using classification, regression, and clustering, and give me the reason why. Do you think build a good model is important in your case? Why? And which one is supervised, which one is unsupervised? Please highlight the difference.